Hello, I'm Dylan Moore. I'm a third-year PhD student at Dartmouth College in the Empower Lab. On behalf of my colleagues, I'm excited to present our paper, Teaching Artificial Intelligence in Extracurricular Contexts through Narrative-Based Learner Sourcing. With the increasing significance of AI in both professional environments and daily routines, being knowledgeable about AI has come to be framed in terms of literacy, as students will need to be literate in AI skills to thrive in a future where such technology is prevalent. To promote learning experiences for AI literacy that are inclusive, immersive, and personally meaningful, our research explores a strategy that combines learner sourcing with the intuitive, engaging benefits of narrative-based learning. The concept of learner sourcing describes a practice of student learning through the collaborative production of shared learning resources. The term is meant to evoke the related process of crowdsourcing, in which a task is split into smaller tasks that are distributed and completed by a pool of crowd workers. The four components of a learner sourcing system are utilize, create, evaluate, and oversee content. Learner sourcing offers a promising option for teaching AI literacy because of its inherent scalability. When a crowd of learners both contributes to as well as benefits from created content, the result can be a virtuous learning cycle. To scaffold the learner sourcing process, we focus on narrative-based activities. Narratives have shown promise as a learning vehicle by promoting student interest and engagement, including in the context of STEM, and more specifically, computing education. Using the mechanics of storytelling, abstract concepts can be explained through familiar and intuitive metaphors. This makes the ideas more accessible, promotes self-regulated learning, and overall creates an immersive and engaging experience. Digital storytelling is often considered an excellent strategy to promote a culturally inclusive environment by empowering participation from traditionally marginalized voices. In grounding our approach, we discuss and build upon various theoretical and pedagogical frameworks. Bloom's taxonomy organizes cognitive learning activities into levels. It is considered a useful framework for educators seeking to craft a dynamic, deep, and adaptive learning experience by interweaving different types of learning and higher-level cognitive skills through a variety of tasks. We also ground our work in the technical, pedagogical, and content framework, also called TPAC. Whereas Bloom's taxonomy focuses on categorizing and structuring educational objectives, activities, and assessments around cognitive processes, TPAC focuses on the integration of technical, pedagogical, and content knowledge for effective teaching, emphasizing the complex relationships that exist among these components. Importantly, TPAC incorporates students' learning context, in particular the context-dependent role of technology. As a basis for our platform, we created our own model that ties together these pedagogical frameworks and the four learner sourcing components. Our model is designed around learners completing learner sourcing tasks that require conceptual and technical AI problem solving. As learners progress, tasks become more complex and progressively emphasize higher level cognition. We designed for a creative, self-directed learning experience that leverages repeated exposure to AI concepts to promote deeper knowledge comprehension through ongoing story engagement. Our top level, Facilitate Learner Sourcing, adapts Bloom's original top level to serve as a learner-enforced check on the real-world relevancy of learner-created content across the platform. In this way, our narrative-based learner sourcing approach aims to prepare learners for engaging with AI in real life. To create our learner sourcing system, we conducted 3 workshops as formative case studies. These helped in understanding learner needs, building out and iteratively testing functionality, and generally understanding how the system might be utilized by diverse learners in a variety of extracurricular scenarios. Specifically, our interface consists of a chatbot-like choose-your-own-adventure story experience, a graph-based story navigation system, and a progress view. We introduced gamification in the form of levels to guide users to reach key curriculum elements by representing AI content and associated learner sourcing tasks as components of a game. Upon reaching a higher level, the game objectives change, and the learner is rewarded by unlocking access to interfaces that afford increasing rights and roles. This is similar to the collaborative model of responsibility found on platforms like Wikipedia. In this way, users gradually evolve from being content consumers to content creators. This is just a brief summary of our system. For an extended visual walkthrough, we encourage you to see the accompanying learner journey video. Our research partner through this process was the Tumo Center for Creative Technologies, a free extracurricular program based in Armenia that provides interdisciplinary educational opportunities for teenagers and young adults around the globe. Through our formative design process, we developed a technology platform that enables a virtuous cycle of content creation, consumption, and peer feedback, with learners iteratively moving up the ranks and taking on increasingly more sophisticated roles that help sustain the educational ecosystem. Our proposed strategy is both significant and novel, specifically in that it addresses a well-documented need for supporting learner interest and engagement in learner sourcing tasks. Through the design, development, and deployment study evaluation of our proposed system, we examine the following research questions. 1. Can a narrative-based learner sourcing platform increase knowledge of AI concepts? 2. Can a narrative-based learner sourcing platform promote interest and engagement with learning AI concepts in an extracurricular environment? 3. What is the user experience of a narrative-based learner sourcing platform? Our specific contributions include an innovative narrative-based learner sourcing approach that uses stories as a vehicle for active, collaborative learning of AI concepts. Instantiation of this designed approach as a usable online platform with features and functionality informed and refined through multiple rounds of learner-centered design. And rich findings from a deployment study that demonstrate narrative-based learner sourcing can provide knowledge gains, topic interest, and positive learner experiences, including for novice learners and those from backgrounds traditionally underrepresented in computing and STEM fields. We measured overall AI knowledge gains through comprehensive isomorphic multiple choice exams administered pre- and post-study. During the study, learners were required to pass AI knowledge quizzes to complete story scenes, making progress in a narrative also a measure of learning. We calculate affective, behavioral, and cognitive markers of learner engagement through passively collected data. Specifically, our platform logs timestamps of all interactions, attentiveness to content, scene edits, and completion of learning activities. Much of this data can be queried and visualized on the platform's analytics page. Lastly, we gathered a variety of qualitative and quantitative markers through questionnaires and interviews. Specifically, we administered pre- and post-study questionnaires, conducted post-study focus groups, and elicited feedback upon the completion of learning activities. Through these means, we gathered data on personal attitudes about AI-related self-efficacy, sense of belonging in computing, readiness to learn, interest in activities, perceived utility of activities, sense of community, and user experience and enjoyment. Having built and refined the platform, which learners in our formative design phase named Apricot Stone City, we next evaluated the platform's ability to promote learning, engagement, and generally positive user experiences. Our final sample consisted of 27 participants representative of the learning community that Tumo serves. A Shapiro-Wilk test suggests pre-study scores were drawn from a normal distribution. We frame the main findings of our study around our research questions. Please see the written paper for more detailed and nuanced discussion of our findings. Foremost, we are interested in examining whether a narrative-based learner sourcing approach can promote learning and increase knowledge of AI concepts. Between the pre-study and post-study AI knowledge assessments, we observed a significant mean increase in performance of 24.2%. Considering a learner to have sufficient mastery of a topic if she could correctly answer 2/3 of the assessment questions, we observed a significant mean increase of 3 in concept mastery from the pre to post assessments. This is notable as there are 10 topics in total. To examine our assumption that content creation is reflective of knowledge gains, we separated learners into 2 groups, those who created content and those who only consumed content. A t-test comparison showed a significant difference, with the content creation group having a larger positive increase in knowledge. While promoting knowledge gains is a central goal of our work, it is also important to understand learner interest and engagement during the experience, as both are core factors in sustaining participation in learning activities and the mastery of increasingly complex topics over time. Early and ongoing interest is signaled by time spent on learning activities. On our platform, learners spent a cumulative 674 hours engaging with content. Of all available AI topics, learners tended to spend the most time on the more advanced topics, such as neural networks. Affective aspects of engagement relate to a learner's emotional reactions to the learning activities. The scenes that received the highest emotional ratings tended to involve traditional elements of Armenian culture. For instance, the scene with the highest rating involved a traditional Armenian dinner. To measure how much participants felt absorbed when using the system and how rewarding they found those interactions to be, we used questions adapted from the User Experience Scale short form. On a total scale of 3 to 15, our analysis indicated a positive user experience on the whole. To many learners, as is captured in the quote, the system's community aspects and culturally centered narratives were a major draw that kept them highly engaged. Across a number of markers, gender seemed to play a role. Notably, we observed no significant gender differences in prior knowledge at baseline, nor self-efficacy. This suggests that any observed differences could be attributable to learners' experiences on the platform. Firstly, we observed a pattern where female learners appeared to have higher learning gains compared to their male counterparts, even though they shared similar levels of engagement. In explaining this difference, we considered attentiveness to content as measured by time spent per word in story scenes. We found that female learners were notably more attentive to content. To investigate this interesting finding, we turned to our qualitative data. Through analysis of the interviews and scene feedback, we found that female learners tended to self-identify with the story's main and supporting character. On the other hand, male learners did not self-identify much with the characters, but they were nonetheless interested in the narrative and focused more on providing metaphors to make sense of AI concepts. These preferences seem to account for the higher attentiveness of female learners to the teaching content. Much of our motivation in developing a learner sourcing platform is this approach's promise in promoting a virtuous cycle of engagement, contribution, and maintenance that can enable the community to sustain itself over time as it grows and to reach its benefits to increasingly broad groups of learners. We were interested in how much organic growth our platform could generate in just 1 week through unprompted, learner-driven word of mouth. During the course of the study, 105 new learners joined the platform and stayed active. By analyzing referral patterns, we observed that new learners tended to join in groups that were linked to a specific referrer. We also found that 2 learners were driving over half of our accepted referrals. What distinguished these individuals was not knowledge, but rather enthusiasm and belief in the concept of narrative-based learner sourcing. This bodes well for the appeal factor and potential uptake of our system. Lastly, we note that many participants were active in community-centered activities, such as our Discord server, where they provided peer-to-peer technical support and encouragement. Taking a step back, we observed that scaling the platform results in not only more content quantity, but also higher content quality as more learners become facilitators. In turn, new and improved content kept learners engaged and motivated their outreach to new generations of users. Encouragingly, we observed a sense of community flourish and persist across 4 learner cohorts. As we enter into the age of AI, we encourage the HCI community to see narratives as an empowering educational tool, as well as a means of combating adult centrism in education. In addition to the positive outcomes we saw for learners across our study sample, we observed that narrative-based learner sourcing can be an effective means of promoting sustained engagement, AI mastery, and self-efficacy for young women specifically. Such findings are especially significant given women are traditionally underrepresented in computer science, and strategies are needed to enhance girls' interest and retention in the field. I'd like to end by thanking my collaborators, the TUMO staff, the generous support of the Dartmouth Innovation PhD program, and all of the learners who participated in this research. Thank you very much.